Hi there, this is Ron Wade with IDT again, and this is the second in our 5-part series on the full-featured PCIe clocks. This time we're going to be talking about clock generators. So the full-featured PCIe clock generators, specifically in this case the 3.3 volt parts, are the 9FGL02 through 9FGL08. As the names imply, those are 2 output to 8 output devices, and there are also 4 and 6 output parts available. So these are in production now. Everything's on the website for these parts. They are PCI Express Gen 1 through 4, Common Clock, and Gen 2.3 SRIS compliant. When you're not using spread spectrum on these parts, the 12K20 phase jitter on the differential outputs is under 2 picoseconds RMS. And that applies to the 3.3 volt parts. We have 100 ohm output devices or 85 ohm output devices in the 3.3 volt range. All the clock generators have a reference output which can be used to save an XO on the board, and the clock generators come in 4x4 to 6x6 millimeter QFN packages. With the 3.3 volt parts, we do have OTP customization at the factory available. You can refer to the data sheets on the web to see what parameters are customizable. And then we also have the complete range of clock generators available in both 1.5 and 1.8 volt versions. There are some additional features common to these parts, and all the parts in the family you can see in the first part, the family overview in this series. So again, we're just reviewing the key features. The phase jitter is Gen 1 through 4. Common Clock, Gen 2.3 SRIS. So you can design these parts in today and use them for a couple of generations before you have to redesign your board. All the parts, the 3.3 volt parts, are 200 milliwatts typical for the clock gens, which is very low power. That's 80% power reduction compared to our legacy 9FG108 type parts. So the heat dissipation is reduced, and if you're in a system that requires Energy Star compliance, this will definitely help you get there. The integrated terminations and the clock generators save up to 32 resistors, which is 55 millimeters square of board area, which reduces both your BOM and the area requirements of the devices. So the full-featured PCIe clock generators, besides having 2, 4, 6, or 8 outputs, have 1 reference clock output, as I mentioned earlier. And this is basically a family comparison of the clock architecture supported. TBD on the 1.8 and 1.5 volt parts for Gen 4, and pin compatibility also across the 3 operating voltages. So IDT has a lot of legacy clock generators in the market. So in this case, I took the 55705 along with its PCI Express Gen 1 and Gen 2 equivalent devices to see why would you want to use a 9FGL04 in place of these 4 output legacy clock generators. Well, the first of all, and the point I'd like to really emphasize, is you are getting much better phase jitter performance. The biggest gap, or the biggest improvement, is probably in the Gen 2 high band area, where you go from 2 and 1.8 picoseconds RMS down to 1 picosecond RMS. And these numbers are all with spread spectrum on. And then the Gen 3 and Gen 4 jitter number is 0.32, which means that you've got a lot of margin to the proposed 0.5 picosecond PCIe Gen 4 specification. And these are all for the Common Clock architecture, by the way. You also get the 12K20 jitter with spread off of under 2 picoseconds RMS, which is not available on the legacy devices. Your board area goes from over 64 millimeters square, and that includes the package and the termination resistors, by the way, down to a 25 millimeter square footprint. And power drops by over 50% from as high as 380 milliwatts down to 142 milliwatts. And you get the reference outputs, which saves you a crystal oscillator. So you've got 25 to 400% less phase jitter, 66% less area, 50 to 90% less power, 16 resistors taken off the BOM, and if you want to save more power, you can use a 1.8 volt or 1.5 volt device for even more power savings. Thank you. That's it for clock generators, part 2 of our series.